Good afternoon, ladies and gentlemen, and welcome to the final session of the MINEX conference this year. So I'm going to try and put a bit of energy into it because I'm aware that everybody is feeling tired. They've had a long couple of days, and they're looking forward to the dinner tonight. So this is, rather than being the graveyard shift, this is the pièce de résistance. This is the ultimate. This is what you've really come for. Yes? Good. All right. So thank you very much for coming along. What we're wanting to talk about is decarbonisation of mining. What does this mean? We'll find out in a moment. We're going to talk about what pressures there are on mining companies to reduce their greenhouse gas emissions. Why are people looking to do this? Why doing something different? All right. And then more importantly, how to be able to do something different. So we'll be looking at some of the practical aspects. So we're looking at renewable energy, we'll be looking at open pit mining, underground mining, we'll be looking at efficiency improvements, we'll be looking at how do you then do the analysis of which option is better. It's intended to be a workshop, it's intended to be practical. If you don't understand something, if you have a question, please ask. We've allowed time for people to be able to interrupt us and ask something, so that way we hope that it will be more useful, more interesting for you all. So with that, let us start. So slides, please. And go. So we're actually now going to move the questionnaire to the end, because we found that when we were asking the questions at the beginning, people weren't very sure of how to answer, and therefore we were getting the vast number of 6 responses. It's a bit difficult for us to be able to understand whether what is the true understanding of the questions with just 6 answers. So we'll now put it towards the end, so that way hopefully you've got a bit more information, and then you can make a judgment as to what you think the next steps should be. So I'm now going to hand over to Nikolai to talk about the why we need to reduce the greenhouse gas emissions.
Thanks, David. I'm going to be speaking in Russian for these slides. So, but the actual slides are in English, so it's like kind of quasi-bilingual. Для чего нам необходимо?
So why? Why do we need to decrease emissions? So mining companies contribute to global warming. There are many aspects to it, and well, mining needs to produce many critical resources which are required for the energy transition. At the same time, mining uses a lot of energy, and nowadays, when plants are designed, the idea is that they need to be carbon neutral, or they need to be able to operate in line with the Paris Agreement. There are more ambitious plans and less ambitious ones. So, the global agreements and covenants on decreasing emissions. Their requirements need to be enshrined by countries at a national level, legislation level. National policies need to be developed for companies to follow. There needs to be legislation, there needs to be strategy. Kazakhstan has undertaken obligations to decrease emissions by 15% compared to 1990 by 2030. So there are no qualifications, no additional conditions, but should additional funding be provided for research and development, then it may get as high as 25%. President Tokayev recently said that the bar for energy from renewables has been raised to 15% by 2030, and we are to achieve net zero by 2060, 10 years later than set by the Paris Agreement. There are various ways it can be done, and many countries do carbon trading, which means companies may procure quotas when they fail to reach certain criteria, but that requires money. Besides, many institutions require companies to have a net zero strategy or to ensure that it is achieved. By the end of 2020, a reduction of 5% compared to 1990 was achieved. It was in Kazakhstan that was achieved. However, we see that the gross amount of emissions is on the rise and is going to take a lot of effort to reverse that trend. We shall see what the regulators can do about it. There are also requirements set forth by the market. There are tax mechanisms which telegraph it to us that there will come a time when you will have to pay for the carbon that went into your product. There are EU acts on batteries under which you are supposed to have a carbon footprint below a certain level. There will be monitoring of sources from materials for those batteries. Many stock exchanges already have special requirements. So not only do they demand that their companies should do proper disclosure, but also they would like the companies to have emission reduction strategies in line with the Paris Agreement or other initiatives. A good example of a working mechanism would be EU Carbon Border Adjustment Mechanism, CBAM. It was launched in October 2022. This will be used during the so-called transition period for industries such as production of iron, concrete, mining, fertilizers. However, this transition period is a period of time when companies have been doing calculations how much carbon went into their products, but they didn't have to pay for anything. This mechanism will start working in earnest in January 2026. That's when payments will have to be made. Then CBAM is to be extended to cover many more industries, and then it will see full implementation. which means that the producers of raw materials will have to pay this tax. It could go as high as 100 euros per ton of CO2 emissions, or it could be per unit of production per ton. Although it will have major impact on the work of mines. In Australia, they have a special mechanism called Australian Safeguard Mechanism. It was launched in late 2023, early 24. It envisages a step-by-step reduction in emissions. So the reduction is expected to be 5% a year. And either the producer works in accordance with net zero, or they procure emission quotas. Another example. This is for minerals used in batteries. There will be special audit held for those in the EU for the total amount of carbon to be calculated per unit. And since batteries have a lot of components in them, it means that companies will have to track the total carbon footprint for those. And if, for instance, you produce lithium and you have produced too much emissions above the threshold, then the company, it will not be purchased by the EU.
All right, so that covers a bit about the why change has to happen, why tomorrow needs to be different to yesterday. What do companies need to do to be able to prepare for this? So, I mean, the first thing is, obviously, is to pick the low-hanging fruit. What is easy? One of the easiest way is to be able to get renewable energy, to buy electricity from renewable sources, because then you can do exactly what you were doing before, the same processes, but now somebody else is making the changes for you. So, for example, in the United Kingdom, over the past 10 years, the emissions for electricity has decreased by 70% because we've moved away from coal towards gas and wind power. So, as a result, somebody else has done the work and we're enjoying the benefit. So that's the low-hanging fruit. No, the cost has stayed the same. The cost increased when the gas went up.
Yeah, but because we moved away from our own coal, our own resource.
I'll go through some slides with you a bit after that. So that's this low-hanging fruit. So the next part is, okay, well, that's not enough. That gets me so far, but not far enough. So what else do I need to do? So we'll go through some of these points. It's going to be things like electrified transportation. So I'll talk a bit about how trucks which you've been using driving on diesel, how do we now reduce the amount of diesel that is being used? What options are there? Improving efficiencies, we'll talk about some of the ideas there. If you've got a coal mine, capturing the methane would be a key part of that, and also changing technology. So these are it's a summary of the actions that companies would need to do to be able to achieve the necessary levels of reduction required. So some of these changes are simple. Some of these changes are going to require either changes in your mining plans because you have to accommodate the new technology, and it may require investments. So, talking about the renewable energy. So first of all, at the moment, coal, the Ekibastos Basin, has been a fantastic servant to the Kazakh industry. It's enabled the price of electricity in Kazakhstan to be about 10%, well, it's helped companies have their operating costs about 10% lower than elsewhere in the world because of the low cost of the coal power there. There is also some good contributions from hydroelectric and gas, with a small contribution at the moment from renewable energies. So that's the moment. But obviously, if we're looking at decarbonisation, one aspect is going to be reducing the amount from the coal and moving towards renewable. So now part of that is also because there's going to be a need for more electricity because the company is planning to grow. In one of the talks yesterday, there was intention stated that the government of Kazakhstan is looking to be able to double the size of the GDP. They want 7% growth per year. Well, there's going to be a lot of electricity involved in that, so they need more electricity. Does it come from coal, or do you add it from renewable energy? So obviously, renewable energies would be one of it. But also, the coal stations, there's a lot of money that needs to be spent on them. So do you spend renewing the coal stations, or do you switch over to renewable energies? So there's a couple of points which are going to drive the changes. Wind. Kazakhstan is a very windy place, a lot of opportunities for it. The cost of renewable energies for wind power, solar power is roughly $1 to $1.5 million per megawatt of installed capacity. So that's the capital cost. The operating cost for these is largely zero. The typical time to pay back a project would be about 5 years, and then there's the opportunity to have low costs. Now, there are some grid costs that need to be considered, but there are some opportunities. So wind is gaining in popularity in Kazakhstan, and there are a number of big stations coming in, and there are projects for another 3 gigawatts of power by various independent power producers, and ERG has announced that they're going to commission 6 gigawatts of solar and wind power. So there's a lot of this is coming in. Now, how quickly? We will see. It is, but certainly it's growing quickly. Solar, as you can see, mainly in the south, but it could also be installed elsewhere. I mean, even in the UK, last week, a quarter of the electricity generated in the UK was actually from the sun. Yeah, it could also be developed elsewhere, closer to where the requirements, where industry and communities are who need the power. Hydroelectric, well, obviously that's got to be linked to the water, and there's limits on how much that could grow. The financing, as you can see, EBRD is ready to fund a lot of projects, but there's also other banks ready to fund. Last year, I spoke to the heads of the EBRD and the IFC for this region, and they said there is money available to fund projects to support the transition towards a low-carbon economy. So there's a lot of opportunities to be able to finance these projects. Kazakhstan is not just one company who provides electricity. There's a number of independent power producers. So it's possible to agree with an independent power producer to be able to provide the power for you. So a company could sign an agreement with an independent power producer to produce it. Over the last 2 months, well, in January and February, Rio Tinto in Australia, for example, signed contracts for a total of 2.2 gigawatts of power to come from wind and from solar power to be able to support their aluminium smelters. So that's going to be, that represents a very significant portion of the installed capacity for Australia. So that's the sort of potential that a mining company can have. And as I said, ERG has said they're going to support the development of 6 gigawatts of power. So mining companies can support the transition and the development of renewable energies. So before I go into the open pits, any questions on the renewable energy side? I think it's fairly straightforward. Basically, you're going to put in a wind plant or a solar plant, and as I said, Kazakhstan has got a lot of potential. Where the wind blows, how much it blows, how the sunshine potential. This is all proven technology, and it is happening, but it still needs to happen faster because, as I said, Kazakhstan is going to grow, it's going to increase its energy requirements, and this is the low-hanging fruit. If there's more renewable energy, then the mining companies need to do less changes to be able to achieve their targets. As far as the targets, many of the mining companies here are matching the Kazakh government's targets of 15% reduction by the end of this decade. But it's likely that the pressure will come on more onto the mining companies because if the choice is between industry making changes or communities making changes, industry is going to be pressured to make the changes. You've got the capabilities, you've got the technologies, you've got the people, and you can also make it work in your benefit because renewable energy is cheaper than coal, especially if you start bringing in carbon charges into the equation. I'm now going to move on to some of the next ones. So we've picked the low-hanging fruit. Now we've got to climb the ladder and actually have to change what we do. We have to do something different tomorrow compared to what we did yesterday. So I'm going to go through a number of points, talk about how to reduce the amount of diesel that's used, because that's the main source. That represents about 40% of the emissions for most open pit mining companies. Talk about improving efficiencies, so what can be done there. And then, of course, there's one of the other areas is to actually take a more holistic perspective to say, okay, how can we work together, the mine and the mill, to be able to reduce the amount of energy required. So I'm going to talk about two methods of transportation in the open pits, and my colleague Chris will talk later about for underground. But one of the proven methods is the trolley assist system. So one of the things that many people don't know that is with an electric drive truck, the wheel motors in the back of the truck that drive the truck, they've actually been sized to be much larger than the engine. So the reason for that is because the wheel motors have got two jobs to do. One is to go forward, and the other is to stop. So for safety reasons, stopping is much more important. So therefore, they are oversized to be able to help the vehicle stop faster. So as a result, they're typically, so when you put a power from the overhead pantographs to the wheel motors, the trucks can travel 80% faster uphill doing it. I know this quite well because one of my first jobs many years ago was at the Rossing mine in Namibia, and my job was the design of trolley assist systems to be able to move them as the mine schedule developed. So this has got significant potential to reduce the amount of diesel that's used, as well as also reduce the number of trucks required, because if the trucks go faster, then you need to use you need fewer trucks. This is actually quite a simple technology, and I would expect within 5 to 10 years, 50 to 60% of the copper mines around the world and iron ore mines will be using this technology. In-pit crushing and conveying, quite a popular process within the CIS region. Not sure why it's so popular in CIS region compared to elsewhere in the world, but this is a very popular technology. Tends to be high capex, low opex, but if you can find the right place for it in your mine plan, then it's a very, because conveying is inherently a more efficient operation, it's a lower cost. Why is it inherently more efficient? Well, your truck, of the gross vehicle weight, 45% of the vehicle's weight is the steel and the rubber of the truck. The other 55% is the payload. So every time the truck goes up and down, half of the effort you're putting in is to move the truck, and the other half is to move the rock. With a conveyor system, what you've got to do is overcome the friction as well as obviously lift the rock. So it is a better ratio, so that is why it's a more efficient system. However, it's also a less flexible system, so you've got to have the right location. So one of the key things is when you're looking at these ones, you've got to be able to look at the mine design. Does it work for my mine? What changes are needed for my mine? So first of all, here is a typical mine. Here is my mining sequence. I use pit optimization software. It tells me to go from blue to green to yellow to red. So I will take this down in cuts. I'll start in the middle, and then I will mine the cuts. That's the economically optimum way of getting the most money first and deferring my costs until later. However, if I was to put a trolley assist or a crusher system, a conveying system in, that would mean I'd have to move it a lot. I don't want to move it a lot, so what can I do to reduce the movements? Well, we can see that up on that north wall, the cuts are quite narrow, so maybe I go straight to the final wall, and I then mine that, then my wall is fixed. And then I can put this system in, and then I can enjoy the benefits of the system. Or, also at the end, I could maybe just focus on the end and put a high-angle conveyor system in at the end. So, as you can see, there might need to be changes to your mining sequence to be able to accommodate this type of technology. A few graphs just to show why. So the top left is your capital costs. So your trolley system and a diesel truck system is about the same cost, because you need to buy, so whatever you're spending on the trolley system, you're actually saving it by not spending it on the trucks. So it actually ends up about the same. You have to do a bit more stripping for a trolley system, but otherwise the costs are similar. Your in-pit crushing and conveying system, well, that costs you a lot more, so that's a bigger amount. But as you can see, the OPEX is better. You can, obviously, there's going to be a lot less diesel used, but more electricity, so it depends on also what electricity you've got supplied or available to your operation. And if you were in an environment where you've got 50% is from fossil fuel, 50% is non-fossil, then you could halve your carbon emissions. So there are a lot of benefits. And a lot of operations are finding that actually this is a good idea anyway. This saves you money, that actually improves the NPV of the operation. It just requires some extra thinking, some extra controls to be able to make the mine work, because these are less flexible systems. Mining companies have also put a lot of money towards some of the equipment suppliers to develop battery trucks. So Caterpillar, that well-known company of mechanical drive trucks, who's been proud to have the largest mechanical drive trucks in the world, well, suddenly now they've issued a 100-ton electric drive battery truck, and they're also doing 793s and 797s with batteries on them. So a lot of these companies they've taken $100 million out of their pocket and given this to Caterpillar, and another $100 million to Komatsu, some also to Hitachi, to develop the battery truck. So this was agreed a couple of years ago, with the aim to have a prototype truck available this year. So Teck, Newmont and Freeport will each be trialling a battery truck from Caterpillar in their operations this year to see how they work, get some more statistics on it. And with the aim that by 2027, so that's only in 3 years' time, there will be fleets of 30 trucks coming out. So they're going to put another $200 million down to be able to buy 30 trucks all battery powered. So this is an amazingly fast development of new technology. And for a company like Caterpillar to go from mechanical drive to electric drive with batteries in 5 years, it's unprecedented. Now, batteries is not the only solution. Hydrogen is another option. So Anglo American 2 years ago, they had their prototype hydrogen truck roll out. So hydrogen, we're talking about a fuel cell here. So the key point is you need to have electricity and you have water. So you have to have a lot of electricity to be able to electrolyze the water to create the hydrogen. And then you've got to compress it, and there's various aspects you do to then enable it to run. The advantage is it's very similar to diesel in the way that you can use it. The disadvantage is it's inherently less efficient. It's only about 30–40% efficient, whilst your electricity systems tend to be about 60–70%, or the battery systems tend to be 60–70–80% efficient. So The advantage of the hydrogen is if you've got a 400-meter deep pit, this could get your trucks out. If you're relying on a battery truck, the batteries would not get your truck out of the pit. So without having a trolley system. A lot of companies are seeing that the future is going to be a trolley system with a battery truck, and it's going to be the way that they're moving towards. So that's what BHP, Teck, and a number of other companies are looking at. It's not just me going blah, blah, blah. These are the operations where things are happening. You can see that with the trolley assist, it was a bit of a slow start. And then it was, so there was a couple of operations, mainly in Africa. South Africa, because they had sanctions, so they had plenty of coal for having low-cost electricity, but the diesel was limited and expensive. So your Palabora, Rossing, Grootegeluk, and some of these other operations went in. But then in Zambia and Congo, because of the hydroelectric power, well, that was, and the fact that you have to truck or rail the diesel into the country, well, that meant it was more economic as well. Then everything went quiet for a while, and then suddenly this pressure towards reducing emissions reignited the interest. And as you can see, a lot of operations going for that. And this doesn't include, so BHP's announced that they're going to be putting trolley assist into several of their mines in Chile. So there is a lot of movement in this area. In-pit crushing conveying, that's a short list, there are more, but that's an area which is more complex to put in. Underground mines, there's a lot of movement towards coming up with the electric mine. But there's also this diesel replacement, so gas, hydrogen, but also biodiesel. So what is biodiesel? So from the waste products of vegetable matter and animal fats go through a hydrolysis process, creates a diesel, which is exactly the same as normal diesel, but it's because it's a waste product, it's counted as having zero emissions or very low emissions. And Rio Tinto has done trials 2 years ago which proved it works just as well as normal diesel. Because of the California restrictions, they need to have, all of their vehicles have to become low emission vehicles. So they're going to go over and take over or take a lot of this up. 10% of diesel produced in the United States is actually biodiesel. So there is actually quite a lot of around, but it does also require there to be a good market for, or a good supply of waste vegetable and oil materials. Improving efficiencies, obviously if you can achieve what you want for less effort, less energy, that's going to be good. Now we're talking about reducing emissions, but how do you do that? Well, I'm going to go through a couple of these points. So grade control, being smarter, just understanding where's the ore, what happens when it gets blasted, therefore you can put more ore through the mill, less waste, it's more efficient, and actually I get more product through it. So it's a smart thing to do anyway, but it also has a benefit in reducing emissions. Review of the KPIs. I go onto a lot of mines and I look at what their key performance indicators are. And largely they're based on what was easy to measure, tons and time, all right, totals and averages. All right. The world has moved on. There's a lot of data available. My colleagues at the back from MTS, this is a lot of things what they deal with as far as taking information that you're collecting with fleet management systems, looking at the sensors that are on board the trucks, and then being smarter. Okay, what can we do with it? What is the quality of the haul road? All right, who is responsible for the haul road? What is good? What does it look like on a haul road? And can we achieve good? Are we achieving the right amount of crushing and grinding? These sorts of things. There are a number of things which are important factors which are currently not being analysed because people have said it's too hard or I don't know how to get that information. Well, it's possible. All right. Go to a lot of operations, hey, open pit mine, it's expected to be rough, it's expected to be, that's why we've got big Tonka toys, because it's a difficult environment to control. Well, it's possible to be able to measure, to see where the trucks are going slower, see what happens. So when a truck goes through a pothole, it twists the chassis. The sensors can measure that. They can drop a flag, say the problem's here. If you present that to the foreman in the morning, he can deal with it in the afternoon. It doesn't have to wait 3 weeks until somebody deals with it. So there's a lot of opportunities there. Shift change. It shouldn't take any more than 2 minutes. All right. The regulations in Kazakhstan and other places says, oh, you must have a policy. The policy is that you must have a policy agreed by the operations and the maintenance manager. Not the details of the policy, but there must be this agreed. There's a lot of opportunity to be able to modify to use the information that's available to come up with a faster and more efficient shift change. As I said, technology. You can understand what is happening, where it's happening, and therefore what can be done about it. When we do evaluations of how many trucks are needed, all right, we apply an 85% factor. Used to be known by Caterpillar as the 50-minute work hour. All right. Well, what happens in the other 10 minutes? All right, can I do something about it? Is that something that's absolutely impossible to deal with? Or is it something I can, well, maybe I can get it to a 55-minute work hour. But for that, I need to know where the problems are to be able to come up with the solutions. I'm now going to hand over to Chris, who's going to talk a bit about the underground. But any questions regarding the open pit side? All stunned. Yeah, so the question...
You need to use the mic.
When you've got a conveyor system, first of all, absolutely, you start with trucks, because you're not going to put a conveyor system in until you're down about 150 meters. All right, so your first part of the pit, you're going to get down to that, unless we're going for an operation which has got a fully mobile system where you've got a shovel loading directly into a crusher and onto the belt. But that's not very common opportunities. So mainly we're talking here about having a semi-mobile or semi-fixed crushing system. So you mine until you're about 150 meters down, find a suitable location, fix it. So all of that opening up of the pit is going to be done by trucks. And then you've got to still use trucks to drive from the face to the crusher to put it in. So you're not going to eliminate trucks, you're just reducing the amount of work, because the uphill haul uses about 8 to 10 times more diesel than just driving on the flat. So the aim here is to reduce the amount of diesel, not to eliminate it.
Yeah, I know in Mexico we worked a combination of that. We had the chapelinis, which were the mobile conveyors, and we had the trucks.
Yeah.
Continue to work. The chapelinis would take it to the point, and the trucks would do.
Yeah, so the comment I'm going to repeat because so that the translation can be done.
Yeah, trying to speak slowly.
Yeah. So
can we please use the microphones,
yeah,
as the interpreters cannot hear your questions?
I'm about to, just for the speed, I will repeat things. So just the comment was that in Mexico, at the mine there, they were able to have a mobile conveyor system, so that way the shovels could load directly into a crusher that followed them, which then loaded onto a belt and took it out. And then also they had trucks as well. So there are lots of combinations. It depends on what your mine is like. What is the opportunity there? So this is why you have to study it. It's different, so it may not be what people are used to, but they need to understand, well, okay, what does it look like this, like this, like this, like this? So there's a lot of opportunities to do it, but first of all, ask the question, and secondly, you need to know how to answer the question. Okay? So I'll repeat. Yeah. So the point here is saying that the mining cost is about 1/3 of the processing cost. So the steps being taken, as I outlined, to be able to reduce the amount of waste going into the process plant is obviously beneficial because you're spending less money in the plant. But also, one of the initiatives that's being practiced is to be able to spend more in the mine, so basically by blasting finer, so that way you can then spend less in the process plant, less energy, so that way, so you need to look at what is the relative efficiency of that. The key thing is you also got to do that in a smart way so that you don't lose your ore. And the other aspect is you then also need to make sure that you distribute the fragmentation so that way you don't end up with a lot of fines and still a lot of coarse. But these are the examples of the holistic approach of looking at your whole project, your whole operation, to be able to come up with a more efficient solution. Well, just one moment, you're going to be given a microphone.
Thank you. I think the second point is when a haul truck drives out the mine, half empty is a real waste of energy and time and money. So making sure your fill factors are absolutely managed and controlled up there. The other one is also making use of lightweight trays, having less steel, which is weight, on a truck, and having more material and rock that you move out. And the truck body doesn't feel the difference, whether it's steel or rock. We want rock out of the mine, not steel, that you're going backwards and forth. And then also, if you have a lot of clay in your mine, that you have a lot of carry back sitting on a truck. So that's absolutely dead weight sitting there, wasting energy unnecessarily.
So the point here is looking at the details. You know, if you've got a truck, do you need to have the heavy-duty truck tray? Can you have a lighter one? And that helps you then have a greater payload as well, so more efficient. So instead of being 55 payload 45, maybe you can get it to 58 42. So that's efficient. But also making sure that every journey is properly loaded so that again, it's efficient, because there's no point in having less load. You've still got the 45%, which is your truck. You know, you don't want to be having less load. So a lot of this is then making sure that you've got good information systems so you can understand what is happening, and then if necessary you can help train people. Whether you can look at the blasting that's going on in the face to be able to make sure you've got a good muck pile so that people can load effectively. So there's a lot of these areas. By improving efficiencies, well, that's good business anyway, but it also does mean that you're going to have less emissions. For the importance, especially for copper mines, where the measure tends to be intensity, looking at how many tons of CO2 per ton of copper produced. All of these improvements in efficiency reduce that intensity so that you end up with less CO2 for each ton of copper produced. Agreed? No. Any other comments? No. All right, so I'm going to have a glass of water. I'm going to pass over to Chris.
Good afternoon, everybody. My name's Chris Bray. I'm a principal consultant for SRK Consulting. So mainly working on underground projects and learning a lot over the last few years on the path to decarbonisation with companies like yourselves represented here. Yeah, I would just say it's great to receive feedback on experiences from operating mines. So if anyone has an experience to share, please do during the discussion, or a burning question that has to be asked. Please ask through the discussion or towards the end. And just before going through some of the decarbonisation considerations for underground, it's probably worth just mentioning that on the why side of decarbonisation, there's a couple of other points worth mentioning. When it comes to international reporting codes for resources, reserves, I'm sure everybody appreciates how important those are. And, you know, a few of us in this room are, act as the competent persons, qualified persons for signing off on those reserves, resources to international reporting codes. And what we're expecting in the years ahead is that the requirement for a decarbonisation plan needs to be part of your mine plan to be able to sign off on reserves. So we're sort of expecting gearing up for this in the future years of, you know, what does a carbon management decarbonisation plan look like? Does it align with what senior management have promised markets, you know, reductions by 30, 50, you know, carbon neutral by 2050. You know, these years are approaching very, very quickly. And when you know, CEOs and so on started announcing these sort of carbon reductions in their plans, me as a mining engineer is thinking, well, who's actually putting together a carbon reduction plan to back this up, you know? There's a lot of promises from CEOs who are probably going to be retired by the time these sort of dates come through, and I'll probably still be there. I'll be on the hook of having to put together a plan that's defending this, that is essential for actually signing off on your reserves. So just want to sort of plant that in everybody's mind that you need to, you know, if you don't have a plan already, we know some of the companies are, all of our clients, we make them aware of it. Some of them are a lot more advanced than others, but you know, this is something that needs to be taken seriously. Otherwise, operations going to run into financing problems if they can't declare a reserve because they don't have a carbon plan that's defendable and aligned with the CEO's promises. So just to make you aware of that. And just to give a bit of background, I guess we started working with our clients on decarbonisation, let's say 7 to 8 years ago. We didn't know a lot back then. There's a lot of emerging technologies with underground mine planning, and we've continued to evolve through that. We also see with a lot of the technical work that we're doing with clients, it's the scene is quite difficult at the moment. You know, we've seen very, very large cost increases over the last couple of years, cost inflation, and I'd say, you know, with base metals in particular, they haven't particularly kept up with those cost increases. We see a lot of mines trying to get off the ground with, you know, lower grades than we've ever seen before, and it's really challenging to even get a mine plan that's getting over the line economically, even with conventional sort of diesel equipment. And then looking at the cost of some of these electric technologies that are emerging, battery electric and so on, they're very expensive upfront infrastructure and capital costs for that equipment. And all of our clients want to go down that path. We've seen clients that once they start on that journey, they don't want to go back. The operators don't want to go back to diesel equipment underground and so on. But for a lot of companies, it's about when is the right time to you know, make that phased change towards decarbonisation, because you've got to have a good balance of the costs versus the change in strategy for materials handling and equipment and so on to reduce your carbon emissions. So when we do a lot of these, all of our mine plans, these days we're looking at the emissions that are being estimated off the back of the mine schedule, which goes towards estimating the type of equipment that's required to implement those underground mine plans. These days we're able to build in conventional diesel fleet, mobile fleets versus fully electric type mines. We're bringing in battery electric trucks. We're looking at opportunities where you can get away from traditional jumbo development, drill and blasting, and truck haulage with, in some cases, TBM tunnel development with conveyors to surface. And just basically it requires more work from the mine planning side of things to assess more options and determine what are the opportunities for decarbonisation. The biggest targets, contributors to carbon emissions that we see coming out of the mine plan, by far usually the material movement requirements. If you've got a diesel-powered mobile fleet of trucks and loaders, by far these are the biggest contributors to your carbon emissions. I guess outside of the mine, the power being supplied for drilling, ventilation purposes is another big contributor to your carbon footprint. And we're also getting a portion of carbon emissions from blasting from the use of explosives underground. So that's what we're seeing as the main targets to cut down on the carbon emissions. How do we go about it? We undertake trade-off studies, looking at different options for it, and trying to understand what is the balance of the cost of implementing those new technologies versus the project economics for all of those options. We are looking at what impact do the mining methods have on the carbon emissions, has a impact on the equipment options that are available, level spacings, whether backfill is included or not. And I kind of see mine waste management is a very big factor in determining the preferred strategy going forward. Sometimes there's a compromise in the project economics just to reduce your waste footprints on surface, whether that be for mine waste, for tailings. But I also understand that some of those more appealing solutions for hiding mine waste back underground as backfill also come with higher carbon emissions because of transporting waste further. So you know, just as engineers, we have our methods of planning, we have more options to assess, and included in the mix now is moving away from our conventional sort of fleet considerations to the decarbonisation options, and also looking for opportunities to, always in the back of my mind is you're always looking to move waste as little as possible, minimise that, and but it's always a compromise with the economic outcomes for those solutions. It does come at a cost. The equipment options that we're seeing are evolving multiple. Oh, okay. So Dave gets he gets 50 minutes, and the rest of us get 10 minutes. So sorry to drag on here. It's a very big area. You know, equipment technologies are moving very fast, and we're trying to keep up with it. We're seeing emerging. You know, the focus has been on battery electric trucks, which are becoming more commercial solutions in underground mines. But now, very encouragingly, we have trolley assist developments with battery electric technology trucks, which look very promising for the future. Hopefully, costs will be coming down. We're also, as I mentioned before, trading off drill and blast versus TBM type solutions, which are becoming attractive as deposits get deeper and more complex. So there we go. I do have a couple of pictures here to show. It's a nice reminder that you can put infrastructure underground for underground processing, backfill plants, materials handling. It can be done at very high production rates if the case is economic and it makes sense. So these are creeping into quite a few of our underground projects these days, and worth considering. The mine ventilation benefits are very significant when sort of reducing your carbon footprint. There's cost savings to be made with reduced ventilation raise diameters, size of fans, reduced ventilation flows for a fully electric fleet. So it's not all increased costs with reduced carbon solutions. And I think this is the last slide. This is sort of the results of a survey, just to show how the technologies are changing with electrical supply, alternatives for underground equipment, looking at the differences of survey results from 2022 to 2023. You know, we're seeing a shift, a lowering of expectations that battery electric equipment is going to be the best solution, and moving more towards trolley assist type systems as being viable alternatives for projects in the future, and biofuels coming in the mix there as well. So I'll hand over to Dave, but yeah, there's lots to talk about in this area for underground mining, and if you have any questions now, please let us know.
Maybe quick. Shafts. I don't see any mention of shafts. And when I started, they were the norm. Then they went out of fashion, and now they're coming back into fashion. Shafts.
Yes, so I actually had a small mention of shafts there. There are a lot of, in the first sort of slide down there, I think second from bottom, it does talk about materials handling approaches. You know, do you go for truck haulage, conveyor, rail, shaft, rail veyor? There's a lot of solutions out there, and shaft is definitely a good option.
Yeah, I meant like it should be, for me, like central to the underground. If I go to underground, like I'm doing in Saudi Arabia. I'm in Saudi Arabia at the moment.
Yep.
Underground mine, and their trucks hauling out, and straight away we're putting in the shaft via raise bores. So, you know, done it in Mexico as well, same thing, converted, put shafts in, leaving the trucks to work underground, and the mineral material coming out, in and out through the shaft.
You know, we a lot of our projects, we're also looking at shaft versus decline access and so on. And you know, what we do find a lot of the time is that you can get earlier paybacks if you go down the decline route. But you know, at depth, shaft does make sense. And but at the same time, if there's a real motivation for companies to decarbonise, they can put that upfront investment in, and that's a you know, you set up.
Similar comment to the open pit option, where we discussed using trucks first, pushbacks, cutbacks, and then you're bringing in your conveyors, what have you, systems. The underground, you're going to go down with your decline, because for the raise bore, you've got to get down to get the point, and then we're not doing the shafts the conventional way. So it's a combination, and the loaders, blah, 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 trucks stay down there moving the ore around back to the shaft, and the shafts bring it out to the surface.
I think you made a really valid point there. You know, and we see this a lot of the time as well. It's a phased approach. You know, at the start of a project, trucks make sense with the decline, but then you know, when you get into stable production at depth, you've got the development there. You can get a shaft in. You move to that phase. You know, so there's distinct phases of materials handling and ventilation requirements over the life of the mine. And when you've got a shaft in there, you've got potential to ramp up production as well. So it's, you know, trucks at depth don't make sense. You know, the truck numbers go through the roof, and so do the emissions. Back to Dave.
All right. We're very aware that we're getting into your beer time, and so bear with us for a little bit longer, because one of the key things is, if beforehand we all did studies, what's going to be the most economically optimum solution. So we work with cash, you know, we've got revenue, we've got cost, this is going to give us the best solution. Now we're trying to say, okay, we've got costs, we've got cash flows, and now we've got emissions. How do I balance those two? So one of the ways of doing that is to create a shadow carbon charge. So this is basically saying, for every ton of CO2, what is the cost of it? When, you know, we grow up and we think that water is free, air is free, so therefore we can use it as much as we want. Suddenly somebody comes along and says, well, actually, it's not quite free. We're going to charge you for it. Well, maybe I can do things a bit differently, and I can be a bit more efficient, and I can value this. So this is valuing the carbon side, putting at a cost. Why $50? It's a consensus view of what it's likely to cost. A number of companies got different values. So Vale has got 50, Freeport 50 to 150, BHP 20 to 60. I know ERG's got a number, but I don't know what it is. what does that mean? Well, $50 turns out is about sort of increasing a diesel cost by about 20%. So maybe I'll make a different decision. My mining costs might go up by 8 to 10%. Well, maybe I'll make a different decision. So the point here is once you add this value in, then you can end up deciding with a different decision. Okay, so how do I do the calculations? All right, scope 1 diesel, very easy, 2.69 kilograms of CO2 for every litre of diesel. There's some slight different numbers. That's the number that the International Panel Climate Change has published, so it'll do for me. Electricity, well, it depends what your electrical mix is, what percentage coal, what type of coal, what percentage nuclear or renewables. So you need to do that calculation a bit more specifically. Scope 3 is complex, but that's not part of most people's plans, so let's just park it to one side for the time being. So it's not actually a complex calculation, it's just a simple one, saying at the top half we're saying I'm going to, the example is invest in renewable energy to reduce emissions. So the top half is saying, okay, what's the pure cash flow impact of this? The second half is saying, okay, what's the cash flow plus the carbon charge? How does that change the economics? The end result is it improves the MPV from $8 million to $57 million to be able to say, well, that is actually starting to be, if I value carbon and if I value it that much, this is what it can improve my economics. Carbon border adjustment mechanism is based on what is the difference between a carbon tax locally in Kazakhstan, that's currently $1 a ton of CO2, versus if you're selling products into the EU either directly or via third parties. So for aluminium, for steel, this could end up being 20–30% of the price. For copper, roughly about 10%. So these could have significant impacts. Maybe not, maybe the EU's too small a market, whatever. It's likely that there's going to be a number of these pressures coming in for protectionist reasons. Okay, we talked about options A versus B, but there's quite often that's not enough. We showed an example of you pick the low-hanging fruit, you've got to climb up the tree, you've got to achieve more. So now you've got to now put a whole alphabet of options together, A to Z. What is the options of those? So one way of ranking them is a marginal abatement cost curve. So you say, okay, each one, what is the impact on my cash flows or my value of my company? And then on the x-axis, what is the amount of CO2 that's abated? Put them in a nice sequence, and then you can say, well, these ones are no-brainers anyway. So if this works, yep, not very well. So the blue and the orange bar, you want to do that anyway, even if there is no question about emissions to be done. The grey bar, well, it's a marginal project. Normally you wouldn't get that past the board, but if you now present it saying, look, this is going to help me with my abatement, it's going to achieve 30% of my abatement, just this one project, okay, let's go for it. You could also package that up for green finance and to be able to then get additional and attractive finance for that. The yellow, well, actually, maybe I want to go for that as well, because it's not going to cost me much, but it again helps me get towards my target. So by putting this range of options together, you can then evaluate which ones to take. So for example, this is the Glencore plan for up to 2035. So they've said, look, we can achieve 6 million tons of reduction of CO2, and it's going to add to our bottom line. So this is what we're going to do. So they've evaluated options and be able to come up with solutions. That's the end of our talk. Any questions? Hopefully it's been of interest. And any questions? Or is it just the bar is more important?
Sorry, is it becoming, is there a bigger market out there? Are there more suppliers for the smaller end? We see Atlas Copco and Caterpillar producing some of the big units. I've seen the Epiroc with the batteries and changing out the batteries. But what about the medium size and the smaller end of the market? Is that being dominated by China? Are you using those examples of that equipment in your mine planning for clients these days? Has that moved on?
I think most of the mine plans that we've been involved with more recently have been in that sort of mid to high production range. So you're sort of aiming for the the largest equipment that's out there that that you can fit in the development drives and so on. But so there hasn't been so much of an appetite that I've seen from clients for smaller, narrow vein battery electric equipment. But I have noticed that some of those smaller suppliers, I think Aramine is one of those groups. GHD out of Germany. These suppliers, I've noticed that they're starting to produce small model battery electric loaders. So the options there, yeah. But I can't say we've been requested to work on sort of smaller scale, narrow type mine plans for that smaller equipment. But it'll certainly make sense, and it looks like there's more options out there. And some of that smaller equipment is not really a great target for the major equipment suppliers. So there are alternatives out there. And
that's why I was sort of asking is the kind of thing that it seems to be is dominated by the Chinese, but there's not a lot of information out there on what's on the market. Just the second comment I had, Dave, about we're talking about all these ways that you could decarbonise. Another one that sort of I've come across recently is the ore sorting and what role that might play. And certainly what I can see from getting really involved in it properly for the first time is that this could be a new modifying factor I can see when you get your resource from the geologists and so there you go, mining engineers, produce your mine plan. One of the modifying factors we're going to take as we go through that process, all right, we add recovery and dilution, which normally takes the grade down. What about modifying factors that take the grade in the other direction and obviously can help reduce your carbon footprint? And I hadn't really thought about it in that way, but competent persons, when they're doing reserves, I mean, that's obviously going to come a part of it and help with these goals. I don't know if you've heard that from anywhere else.
Yeah, that's a very good point. Ore sorting is gaining a lot of interest. And in fact, our office in Vancouver has got 50% share in an ore sorting laboratory to be able to evaluate the potential for ore sorting, whether it is, there's some suppliers which have got sensors in buckets for shovels to be able to do it on a bucket by bucket basis. There's also sensors you can do for trucks, as also on the belts. Exactly as you say, it's going to be a factor. Now, to me, it's no different to loss and dilution, and it's, as with all signing off on all reserves, you've got to be transparent of all the material factors. So absolutely, it's a modifying factor. It may not be explicitly defined at the moment, but it's absolutely a modifying factor and therefore would need to be described. Going back to your first point, we're actually seeing in open pits a move towards smaller trucks, whether it's either smaller trucks from China, but also from Scania and other companies, because they're able to get in the battery trucks into these smaller units. They're happening right now. And one of the advantages of smaller trucks in a large pit is you could be talking about a 15-metre wide ramp instead of a 30-40-metre wide ramp. So therefore you can be able to bring it down, you can get into ore faster in certain circumstances. So, so we are seeing actually a bit of a move around, so it's not just we're doing a battery version of what we did beforehand, it's now actually changing a lot of the pictures. So thanks for those questions, they're very good ones.
Mike, just on that pre-sorting note, this is becoming more and more popping up as being essential for our clients, but we do find that we do see that they're on the back foot. They haven't done the pre-sorting test work to defend the assumptions going into the mine plan. So really encourage companies out there to really consider whether pre-sorting is interesting and get your test work done as soon as possible, so you know what benefit it's going to give.
No, absolutely. That's how I came across it. I had a client who had the ore sorting test work done by one of the equipment manufacturers, but they didn't understand the report. And that's how I got involved with Adrian in working out what was going on in SRK Vancouver. But the other point I was going to mention was about we mentioned about all these figures and things and about how much carbon you're producing and the cross-border adjustment mechanism. I mean, the killer question, I think, is who's going to be the arbiter of all this? Who's going to sign off on how much carbon you've produced? Or you produce these statements about the carbon in your product you produce from your mine and your emissions, who is going to police that to stop companies under-declaring the amount of carbon they produce? Because there's a lot of money attached to it. And you see that Tesla last year announced 1.7 billion in revenue that they had earned from selling carbon credits based upon the cars they're selling. So there is a real tangible market out there with cash in it. And I just wonder, I mean, that's quite easy that you can calculate the amount of carbon a car can offset. But in some of these other numbers, how much you're generating of different kinds, who's going to police that?
So, I mean, as of the 1st of January this year, all importers of specific materials need to declare what is the emissions associated with those materials that they're importing. So either as directly or within the product. So if you bought a car, which is an aluminium body from China or whatever, or UK even, you'd have to then, they'd have to provide a certificate saying, over the past year, this is where we sourced our aluminium from, and therefore it's got, this one is at this percentage, this is this percentage, this is this percentage. In the IFRS S2 reports, again from the 1st of January this year, companies need to make declarations on these emissions. Your auditing companies, your Ernst & Young, Deloitte, KPMG, loving it at the moment because people need to audit these very things. And of course, they're very well placed to be able to do that because they have these processes in place. So absolutely there's going to be rough edges. Absolutely there's going to be a lot of games being played. But the point is it's getting tighter and so on.
So the answer is it's not the technical consultants, it's the accounting firms that are going to be doing this.
Unfortunately, on the scale we're talking about, yeah, we can only advise them whether they should go left or right, not how much it's going to be. Sorry.
I was just going to mention, we've just finished an ore sorting study, again in Saudi Arabia, and we abandoned it because it would close the mine. We built a new plant, a zinc plant, and we would be out of business in half the time, 2-3 years from now we'd be done. So we actually backed off it and carried on with our current practices. So that's all. On the smaller trucks, we've done exactly that. We've got these Chinese trucks into the open pit, and it's like a lease of life. You can go anywhere you want with them, and narrowing down the roads, and it really does work. That's a real big benefit.
Yeah, so the ore sorting, it's a horse for a course. It's not perfect, and it's quite a complex thing. It's a holy grail type objective. If it could work perfectly, fantastic. But it's difficult, especially to work in a operating environment. But this is why you need to be doing evaluation. So the point here is that tomorrow is different to yesterday. There are different questions, different answers. And I just wanted to help everybody be aware of these particular points so that way you are all better informed to be able to look at things in a different way. Any other questions? Or is everybody feeling thirsty? I am. Well, on that note, I'd like to thank everybody for coming along. I hope it's of interest. And as I'm the last speaker, I would like to thank the translators for excellent job over these last 2 days. So please, a round of applause for this translator. We do have a questionnaire which we can fill in, so those who are not desperately thirsty, please fill that in, because we would like to know what people's ideas are about things going forward. Again, and if anybody's got any other questions, we are available. Happy to talk. The slides will be published when everything goes up onto the website. So if you want to look at that, if you need a Russian version of this, please let us know and we can get it translated. So thank you.